this, and whoever else wants it. Okay, and then
Oh, okay. I think the next topic is classification tree. That's probably what we'll
Right.
cover.
yeah,
Is that chapter 8?
no, chapter 8 is time series forecasting,
Uh,
which is now going to be optional. Okay. So we're looking at K nearest neighbors. Okay. So this is based off of the Pythagorean theorem, or what's called the Euclidean distance. And so, you know, if you have A here and B and C, you have A squared plus B squared equals C squared, right? Perhaps if I drew an equal sign, better. Or more generically, you know, A squared plus B squared. And so it turns out that as you go up in dimensions, like if this is your X and that's your Y, and then this is a Z axis, so three-dimensional, that you can calculate the distance between 2 points using the same general formula. So the distance from here to here, the origin, you know, so if you have a point at 0, 0, and a point at, let's just call it 1, 2, 4, that the distance is equal to x1 minus x2 squared plus y1 minus y2 2 squared plus z1 minus z2 squared. And if x2 in this particular case, you know, so if I'll just do it this way, if x2 is 0, 0, 0, then this just becomes x squared plus y squared plus z squared. So this is the distance formula in 3D space. And there's proofs to go through with it, but if you just accept it that two-dimensional space, it's, you know, x squared plus y squared. Three-dimensional space is x squared plus y squared plus z squared. And you have a general formula that the distance in n-dimensional space is equal to the square root of the change in your first variable squared plus the change in your second variable squared plus the change in your third variable squared plus all the way to your nth variable squared. Okay, so this is kind of the general formula for distance, and it's called the Euclidean distance. There are other distances that you can use, but this particular distance has some nice properties that makes it really useful. Do you have any questions there on that portion? Like what distance means and how you might calculate distance in using different variables?
Nope, that makes sense.
Okay. So basically then the principle of k nearest neighbors is, I'm just going to do it in 3D, or actually we can do it in 2D because the principle holds. You basically plot all your points. And something like that, right? And your K is you're going to start calculating the distance between all of these individual points. And what you're going to do is you're going to look at, you're going to pick a point. So if K is equal to 2 or 3 or 4, or you can even do 1, you're going to look at your nearest neighbor. So if K is equal to 1, like this guy here, this here might be the nearest neighbor. And you say, okay, I don't know who I am, but this guy right here is a plus. So I think I'm a plus. And this person right here says, I don't know who I am. You know what? Actually, I need to maybe draw in some, let's get in some minuses. Okay. So this one right here says, I don't know who I am. So I'm going to go to my nearest neighbor. And that's also a plus. So this point here thinks he's a plus. This one right here says, hey, that guy's the closest. So I think I'm a minus. So this is kind of the general idea is you go and you look around you and you see who's the nearest to me and you decide who you are based on who's closest to you. So for K equals 2, like this point right here might say, hey, that one and that one are close to me. I'm a minus. This one right here might say, hey, that one and that one is close to me. So I'm somewhere in between a plus or a minus. And I don't know how it decides which one is closer there. But, you know, you kind of take the average of these two and maybe whichever one is stronger gives you what you think you are when you're close by to 2 of them. When you're close to 3 of them, you know, you basically look at your 3 nearest neighbors. So this one here might look at, you know, this point. So this point right here might look at this guy, this minus, and this minus. And it says I'm a minus, and a plus. That means I'm a minus. And so basically, the K nearest neighbors means you're not actually trying to, for a new point introduced into the data set, you're not trying to fit a curve to it based off of all of these properties. You're instead just taking the distance, finding the distance between you and the other points closest to you and saying, hey, 3 of these things close to me look like that. I'm looking at a K equals to 4. I'm only looking at my 4 nearest neighbors. 3 of them are a negative. 1 of them is a plus. I must be a negative. That's the basis of the entire K nearest neighbors algorithm.
So do we run the kNN in multilinear regression too, or?
You can do it in both logistic or linear regression.
Okay.
Yeah. This
And
concept
that's what
of,
you did on yours, right? You said you ran both.
yeah. So well on ours, it is only ours is a logistic regression problem. So I only ran logistic regression for kNN.
Okay.
So, but if we look,
What's up?
if I go share this desktop and then we come in look here. And we can work one of the examples in Excel, so we can see how that's done using the tools, using those tools. But here's a kNN example, and here I step through the different kNNs, and I'm looking at the accuracy that comes out of this analysis and the F1 score, and you can kind of see how it's a sawtooth. Which, and and it's sawed specifically wherever it is. It's a hot. We have a better score whenever it's an odd number, and a worse score whenever it's an even number. Just something to note. I don't know if that's expected. Remember how I was saying that when there's a tie, I don't really know which way that it goes. That might be reflective here, that when there's a tie, you just kind of lose confidence that you're guessing the right, that you're getting the right identification. But this is generally what kNN is.
And the one on the top is, what is that line? The blue?
That's the validation accuracy. And to be honest, so this is against our data set. And I'm surprised that it is as flat and steady as it is, right? The F1 score gets worse, which means that as the number of as I increase the number of neighbors that I look at, the ability to distinguish between truths, between class 1 and class 0 seems to be getting worse.
Mm-hmm.
Yet somehow my ability to correctly identify them within the data set is staying the same, which I don't really understand. But it's what this tells me. So I have to look into it a bit more. But maybe we can do a kNN problem from the problem set. But in terms of like the underlying theory, does it make a little bit more sense now of how this method works?
Yeah, I think so. It'd be nice to see it in Excel.
Yeah.
I think you said you're going to show that.
Yeah, I mean, this is the equivalent of like finding yourself in the middle of a crowd and then ask, like, imagine you were at a political convention and you look around you at red or blue shirts and you decide what political party you belong to based off of, are there more red shirts or more blue shirts around you, without looking at your own shirt naturally.
Would you say that like kNN is a bit more subjective and then the other like multilinear regression a bit more objective?
No, I wouldn't say that at all. There are different methods of classification, and I would say that this method proves superior when there is clustering of points in n-dimensional space. So this is probably it's indication of a highly clustered data set, I think. I guess is the way that I would think of it, that points that tend to be the same tend to be located closely together across this n-dimensional space, which is slightly different than fitting a line through things. I'll have to think about that. But it's just a different mathematical technique. And, you can use the same measure of accuracy of F1 score, precision and recall of a confusion matrix to determine, if it's a good fit or not. And so it's just another method. I don't think terms like subjective or objective really fit well in terms of the underlying mathematical basis. Maybe in terms of how you interpret it, you might think of it as more of a subjective interpretation, just, classification by association.
Yeah, I guess I was thinking more from that light. I was like, well, if you use this, aren't you kind of more prone to bias or something?
That's a good point. You may be. But, maybe in a data set where the separation between the classes is more prone to bias, maybe it works really well. I think one of the nice things about this Trying to remember. Actually, I don't remember if it's computationally expensive or not. Actually, I mean, when I ran it, it does actually take a little while to run. But, well, let's go see if we can, let's go find a problem. Do you know what problems we need to work on for problem set number 3? Anybody have that up?
Don't know off the top of my head, but I can look.
Yeah, I'll go find it. Okay. Problem 9. Blue or red sample data. Classify using K, nearest neighbors, K1 through 10. Use age, homeowner, female as input variables, undecided as the output. Standardize to adjust for cutoff probability 0.5. Minimizes the overall error rate, and compare validation and test sets. Okay, so let's do that. So this is problem 9. It's called blue or red. Okay. Let's make these a little bit bigger. All right. Go ahead and convert that to a table. All right, and then we're going to come over here to data mining. This is a classification. So remember that kNN can be done both using in linear regression, so predicting a continuous variable, as well as predicting a categorical.
Classify. Yeah.
Okay, so first data contains headers, and we wanted undecided as the output. And then we wanted, age, homeowner, age, good boy. Okay, age, homeowner, I'll put that over there. Female, household size, income, education, and church over here. We're not using married. Okay, and it says standardize. So we're going to hit next here. And it's going to ask us to, so we're going to partition the data. And we're going to use the partition data column variable. It doesn't say to do that, but I'll just assume that we're doing that, because I think the book problems usually do that. And then we're going to rescale the data to standardize it. And are you clear on what standardization means?
Nope. Can you explain
Nope.
that?
Yep. So standardization is nothing more than doing the calculating the z-score. So it's okay. So standardization for every point, for every x, you're going to calculate a z of x, z sub xi, which means you're going to calculate the mean of x, the standard deviation of x, and each of these xi's is going to become a, x I minus mu over sigma. That's it. So it's just this z-score, if you remember from statistics and having a normal distribution and a normal plot. There's a couple of others in there. There's normalization, which is an individual x over the sum of all x of I squared. So this is basically the distance formula. So you take an individual item and you divide it by kind of the length of the entire vector set. And then there's a unit norm, which I think is you find the min and the max, and your unit norm is equal to your xi minus the min divided by max minus min. Sorry for my horrible writing, but so what the unit norm does is this here translates everything between a 0 and a 1. This here translates to everything, in terms of standard deviations away from the mean. So 0 means it's the average, 1 means it's one standard deviation, etc. If you remember that thing we looked at a long time ago, if in a normal distribution, 68% is within one standard deviation, 95% is within 2, something like that. And then the norm, this is the normalization is also a number between 0 and 1, but based on the total distance, based on basically the portion or weight of the number. So they're all basically different ways of trying to make numbers have the same magnitude. And the reason that you want to do something like this is this. Let's say you're looking at house prices. And here you're looking at number of rooms. And over here, you're looking at prior comps. These numbers here might have 7 or 8 digits. These numbers here is going to be like 1, 8, 11. And so a very small change in this number represents a huge change in this number. And it's hard for algorithms to minimize the error when these numbers are so big, because if you remember, the calculations are y minus y squared to calculate the error. And you're trying to minimize this. And when you start looking at these things that might be really small and these things that might be really big, the math gives more priority to these numbers of larger magnitude. So you don't want that. You don't want this part here, this part of the equation, to count more than this part of the equation, unless you know for a fact that prior comps is way more important than number of rooms. But usually when you're trying to do a regression problem, you're saying, I'm not going to assume anything about any relationship. I want the math to tell me if there's a relationship. And so rescaling is basically just a way of changing the number, but essentially keeping the information the same. So you can take all of the original numbers and convert them back to z-scores. It's a very easy translation, and you get very nice numbers between 0 and, by the time you get around to 6 standard deviations or so more away, like you're really dealing with very small portions of your data set. And the same thing with these normalization and min-max. And certain algorithms demand this more than others. So for the k-nearest neighbors, because you're dealing with distance, you can imagine how you want all the numbers to be roughly the same order of magnitude. Otherwise, this you know, these terms right here in the distance will just start to dominate the equation. So if you can get everything to look nice, maybe around like a 0 or a 1 in between there, you can get much more valuable information from these other types of methods. Does that help? Yes? Kinda? No?
I will be replaying this portion of the recording.
Okay. Well, I'm hoping I said it right. This is the general thing, though. You're just trying to translate the numbers into something where they're all roughly equal, so that when you do a distance calculation, one term isn't so much larger than the others, that small variations in that term are more important than large variations in smaller terms. You know, so it's like if you're looking at that house price with prior comps in the millions of dollars, you might have a number that changes by $10,000. And on $1 million price point, that's meaningless. But a change of 10,000 compared to the number of rooms is ridiculous, right? You wouldn't go from 8 rooms to 10,000 rooms, but you just did here in this comp. And so how can you kind of equate small changes on a number that's this big to small changes, you know, in a number that's this big? And so there's a bunch of different techniques that are used for that. Standardization is one, normalization is another, and then the unit norm, which I'm pretty sure is min-max, something like that, is the next. And again, I could possibly be wrong on which one is which, but under the hood, that's kind of what it's doing one of those three. And for the purposes of the exercise, for kNN, you just select standardization and you let the software do its thing. You don't really have to think much about it. If you wanted to, you could try to solve the problem without standardizing it and seeing the answer you get, and then solve the problem with standardization and see which one is more accurate. That's probably the best way to go about.
I think when he went through this, he had to standardize it though, right?
Say that again?
I think when he went through this, he had to standardize.
Yeah, he did.
Yeah, use standardization for kNN, which I know because that's what he said. It's not super obvious where you say like, oh yeah, of course you want to use that. I mean, one nice thing with standardization is you do kind of have a 0 and a plus and a minus, so you know where the middle is. So if you're right on top of something, that's a 0. You know, maybe that makes the math a little bit easier. Not from a computational point of view, but I mean from like the way that the distance formula works out. Maybe it's you get cleaner results when you're centered around 0 than if you're centered around 0.5 and everything is between 0 and 1. Anyway, we're going to say rescale with standardization here. Somewhere in this, it should ask me where my K is. Prior probability. I don't think coefficients or anything matters. We're not doing feature selection. And next on the score, we're going to go ahead and pick lift charts. What else did we want? Error rates, summary, summary, summary. Okay, I hope this is going to ask me. It didn't ask me about Ks. Did I not pick kNN?
I thought you did, but
So did I, but it seems that it did logistic regression. Yeah, that's all the same. Okay.
oh, it says fixed K.
Yeah, I must have not done, I must not have selected kNN. So we're just going to go ahead and do this again. We're going to use partition variable as partition. We're going to rescale the data using standardization. And it wants, the book said to do between 1 and 10. So we are going to do between 1 and 10, search. Oh, this is a problem. Oh, never mind. I forgot how this works. We put in 10 up here. So it's going to search between 1 and k being this. And we're not going to worry about prior probability. Prior probability, by the way, is just if you want to use a previous result, or if you kind of assign things. Actually, you know what? I'm not certain precisely what that is. Usually, it's an initial initialization of weights. I don't know how that works in k-nearest neighbors. We're going to go next. We'll still keep all those. Go ahead and look at the lift chart. And now we're going to let us do its thing.
Yikes.
Yikes. Try that again.
So 20 is just really finding the 10 is just finding the 10 nearest neighbor, right? Like the 10 closest points.
Yeah. Yeah, it goes out to the 10 closest points and it does some math and it says, okay, based on these 10 things surrounding me, 10 nearest things surrounding me, this is who I think I am. And it does that for every single point, new point in the data set. So unlike previous methods, you don't actually have to pre-train the model in nearest neighbors. You just simply give it, here are all my previous points. I'm going to give it my new points. And then for my new points, I'm going to go out and I'm just going to go find who's closest to me. You don't pre-train it like you do in logistic regression, where you run and calculate all those coefficients first. Do we want to continue where I was working off? No, we won't, because I don't know why that last one broke, but we're not going to deal with it. And try this again. Data mining, classify, k-nearest neighbors this time. And if this doesn't work, one of you will get to run it. Let's see what happens. Okay, again, we want undecided is the output variable. And then age, homeowner. Go over there. And then we want female, household size, income, education, and church. We are left with married and partition. Go next. Partition data, partition, use variable. Select that. Done. Search K. Go 1 through 10. Next. Let's go ahead and leave that. I still want the lift chart. And let's see. Come on, Excel. Sure.
Why is that?
I have no idea. Column index out of range. Data. It's split up between training, validation, and test. All that's right. Success class is good. We're through A1 and J10,001. Those are that. Partition data. Oh, you know what? I didn't rescale. So we're going to rescale. Come on, drum roll.
Are you guys able to get the problem set 3 downloaded? Because somehow I'm having trouble.
Yeah. Well, I've been having trouble with my Chrome, so I have to. Never mind, I
Okay,
have
here we
my
are with the
notes.
output. Assume it's going to update at some point, not just be a blank screen.
Mark,
Yeah.
you know, on some of them, he didn't do rescale, and then this one you were doing rescale. Can you just quickly run over why you're doing rescale?
For k-nearest neighbors, you want to rescale the data to use standardization.
Okay, got it. Okay, thank you.
That's why, and that's based off of what we were talking about before. In that, when you're looking at dissimilar numbers, where maybe one of the numbers is, not single numbers like the number of rooms in a house, and other numbers are millions of numbers, like in the order of magnitude of 10 to the 7, like the price of a home. That a small change in the price of the home is weighted the same as a massive change in the number of rooms.
Okay.
Even though they're not the same, right? So a change of $10,000 on $1 million home is a very small change, a 1% change, whereas going from 1 room to 2 rooms is a 50%, is 100% larger.
Right.
But the math from the distance will say, hey, that thing changed by 10,000. That's massive, because remember, it's the distance, it's x1 minus x2 squared.
Right.
So at that distance, you're going to have 10,000 squared, which is a big number.
Yeah. Okay, and that's why you rescale it.
That's why you rescale it. So you're dealing with numbers between 0 and 1 relative to itself.
Okay, thank you.
And then when you go to calculate the y and do the prediction, you have to rescale, you have to transform your new, sorry, not the y. When you go to give it new data to test, you have to transform the new data the same way you transformed the original data. So just keep that in mind, that whenever you do a transformation, you have to do it across the board. And so here we have our K1 through 10. We're going to find the one with the lowest misclassification rate, which seems to be number 5. Does that look right? It tells us that the scoring is done using K5, so that's good. Okay, and then Andy told us that the F1 score for the test set is 0.9295. So let's come over here to the test set, and let's look at our F1 score, which is not what he said. Or any of these numbers what he said. And this was chapter 9, problem 9, right? Campaign organizers, cutoff, 1 to 10. Well, I don't know what we did different, but I don't think I did this one wrong. So I don't know what to say about that. On problem 9, include marriage as an independent variable. The omission seems to be a typo. So that's why we got a different number. He said to include marriage as an independent variable. So we are going to delete the runs. and we're going to rerun this, classify k-nearest neighbors. All this will repopulate. We're going to toss married back in. Everything else should be the same. So I'm just going to go ahead and hit finish. And we'll wait.
It's better than some of the systems I wait on for work.
Yeah, now I'm nervous it's going to crash.
The cloud is slow. I'm telling you, when I have to do this on the cloud on Saturday mornings, I have to run it like twice sometimes because it'll crash out halfway.
Wow.
Ta-da!
Yeah. Now let's see if the K's changed. You got to wait for it to finish its calculations. Be great to be able to edit waiting out of real life. Okay. Let's see, did K change? Still number 5. And we're going to go look at our test score. F1, 0.9295, 0.929. We'll call that 9295. All right.
Good to me.
Looks good. Okay. And so then what else did it ask? It said for a probability cutoff of 0.5. And if we'll remember, that is the probability cutoff when you're running the regression is set here in this, when you pick the success class and when you pick the success probability cutoff. Oh, it doesn't like, because I'm not on the same, I'm on a different page. It wants to be on the data page to do this, but you can kind of see success class and success probability. So whenever you're changing, you can change this probability cutoff between 0 and 1 right here. But I'm not on the right page to do that. So and then it says compare the overall error rates and test sets apart from A, explain the role of the test set and the implication of these particular results. Does anyone want to take a crack at explaining well, let's look at the training score and the validation score. So here's the training score. And we have an F1 score of 0.94 and an accuracy of 95%. Our validation score, we have an accuracy of 94. And on our test, we have an accuracy of 94.5. So does anyone want to take a crack at explaining the overall error rates?
Isn't it supposed to get worse?
That's a good question. Let's actually.
It should get worse. That's what Andy kept saying on last Saturday. It's
Oh, you
supposed to
mean
get worse.
between training, validation, and test score?
Yeah.
Yeah.
Yeah. So it should, in general, it should get worse, but a little worse. If it gets much worse, if the training set is significantly more accurate than the test set, where significant is in general subjective, but I would say in practice anything more than say 5%, you should start to get suspicious. when the training set is much more accurate than the test set, it means that you've overfit the data. And what that means in layman's terms is that you didn't learn anything about the relationships between the independent variables and the output variables. Overfitting means you memorized the input variables against the output variables. So, it's the difference between memorizing things in school and actually understanding how to use them in real life. And when the training set is significantly more accurate than the test set, it means you didn't learn a thing, you just memorized all the training set. And that's generally bad in the world of predictive analytics, because it means then you wouldn't expect to perform well against data that you didn't train on. And it says, compare the overall error rates on the validation sets and test sets. So in terms of this one here, we have 95%. If we look at the error rate, we have 2.2 and 6.6. Here we have 4.2 and 8.4. Here we have 3.6 and 8.3, but the accuracy rate stays about the 95 to 94. So what do you all think about the results? Does it seem to indicate overfitting? Does it seem to indicate it's okay?
I don't know if I saw it right. It looked like the validation is the worst of it, and then tests actually got better.
Yeah, it does look like that. Now remember that I don't know how this data set was partitioned, but the data set is partitioned, and it could be randomly that the validation set is not as random as the other two. Maybe randomly you picked a whole bunch of zeros, for instance, or a whole bunch of ones. So it can happen. A lot of times what you do is, if you suspect that that's a problem, you're gonna essentially, like, you'll rerun, you'll randomize the partition selection, and you'll rerun it like 20 times and average all the results. And if on average you see that the training is about equal to the validation set, and sometimes it's a little higher, sometimes it's a little lower, you don't worry about it. It's just, it happened. If you always see the training significantly higher than the test set, it means that you're overfitting. So, what this tells me to my eyes is, now these percent error rates, the training on the individual classes definitely seems to get worse but it's not significantly worse, and it's kind of in the direction that we expect. So the accuracy, whatever it's doing is fine, but these percent errors are getting worse, but slightly worse. And we can look at the tests at the lift chart, decile chart, everything above 1. And it does seem to get better as it goes along. We look at our ROC chart. Ooh.
That looks good though.
Yeah, that looks very nice. And then this is the lift chart, cumulative versus total number of cases. So looks good. All right, we have good separation, and which matches this, by the way. When we look at the training score, the percent error in identifying class zeros is 2%. The percent error in identifying class ones is 6%. So we have to work a little bit harder to find ones, but these are relatively small errors, so that kind of tracks this kind of a curve here. All right, that's problem 9. Let's look at problem 13. Telecommunications company does stuff. Classify using 1 to 10. Churn is the output. Everything else is input. Standardized. We ask a question about churners in the training set, about validation and test. We look at a cutoff probability of 0.5. We look at the class 1 and 0 error rate. So this problem here, problem 13, is almost exactly the same as what we just did. So do one of you want to do it? Come on, someone can do it. I'll walk you through it. Who's going to be our YouTube star? Come on.
Someone do it, and I'll promise to do the next one.
Amy, Victoria, Jimmy.
I'm laughing so hard in the background.
You want to give it a shot, Victoria? No.
Not
Do
really.
it, Victoria. You can do it. It's really easy. It's just kNN.
Come on, Ben. You go for it and I do the next one.
Oh, I can't. I'm sewing something right now, so I'm just watching. I got a stuffed animal that I was chastised for not sewing for weeks. So my son.
Can you do the problem I sew?
You want to sew while I do the problem? Sure. If you come over here and sew a stuffed seal, I will do the problem.
So I wasn't able to download the file. So
Here, I'll give it.
So the file it's not in the problem set file. It is in the class set file. The data set is in the class set. So the problem set file, all it does is it just has that one PDF in it that says do these problems.
Well, 9:13.
no, it's my
Dude.
Chrome. Chrome's been acting up for me.
Oh.
It keep popping up save as, but it's not like the things I want to save. Let me see if I can download somewhere else.
Gotcha. Okay, so cell phone.
Yeah, I wasn't even able to pull up that problem set number 3, that PDF.
Yeah. Oh, okay. Here.
Yeah, but I took a screenshot of what you have.
Okay. Yeah.
Yeah, I tried to have a look at it and it's not loading. But
Okay.
Chrome did let me download it without loading it.
I think, yeah, that they did say there was some issue with Camino or something.
Okay.
Had me going on. Okay, so both of those are posted in the study group now then. All right, stop share. Who's got the con?
I can do it. I just hold on. I need to find this
Awesome.
thing.
Yeah, I'm gonna be right back. I go get my tea.
Like I have too many windows open. So confusing.
Is that because of your strategy project? I have a billion windows open because of that project. Like
yeah.
every time I
was gonna say,
Google
think
something.
it's our Airbnb data ruined our computer.
Well, that's Airbnb for you, just ruining everything, right? Ruined the hotel business, ruined your computers.
Wait, I can't use Slack on IE. Oh, that's just great.
What do you mean you can't use Slack on IE?
I tried to use Slack on IE, and it says this browser is no longer supported. What in the world? And I
Oh
can't
yeah,
use-
because they moved to Edge.
Oh, is that why?
Yeah, so when everything like Microsoft they're forcing people to move to Edge because IE is such a disaster.
Oh man. Okay. Hold on. Well, I don't really like Edge, so that's why I haven't been using it.
Edge has the weirdest thing. So we have a system where we print badges at work where you're supposed to be able to you're supposed to print, but the print settings are you gotta turn off borders and you got do a couple of funky things to print. Edge just will not let you do it. It is shocking, actually. It refuses to let you change any of the printer settings besides the Windows default printer settings. I don't know what's going on with that program.
You know what? I'm just gonna close everything because this is just not working for me. Hold on.
Number 13, which one is that? Which file?
Mark posted it to the
Yeah,
Slack, so I was trying to download that, but my Chrome has just been giving me issues.
Do you use the desktop version of Chrome of Slack?
No, I don't.
Ah,
So what happened? Well, I'm using like my work laptop. The I don't know what it is. Something to do with Google Drive, and I can't figure it out. Every time I have anything Google Drive related, it will just keep trying to save the file. And then because I've been collaborating using Google Drive, like I just and every time I keep clicking away, it just keep coming up, and it's just very annoying.
Mark, what's the data set's name for problem 13?
cell phone.
I got it. I have it open now.
Okay.
Share screen.
All right.
I have no clue what I'm doing.
Okay. That never stopped me.
It's the best way to learn.
Exactly. You got this. Look at that. Clicking with confidence.
It's my favorite thing to do, just click. I think churn is the independent, right? And then everything else is.
Yeah, more or less, except for churn is the dependent, but yeah, in spirit, you're right.
Sorry, yes. But that means I have to leave out partition.
Check. So let me double check it. You got what are we on 13?
13, yeah.
It just says everything.
It won't let me use partition for some reason.
Um,
Invalid inputs with non-numeric and.
Oh, it's because yeah, it's
Does that mean you have to?
it should work. It should work now. Yeah, it was loading the data set. It should work now. I've had that issue too, where if I tried to rush it a little bit too quickly, it would get mad at me. But it should allow you to now.
Oh, really?
Sewed seal. We are good. We have a patched up little seal.
well done. Well
Oh,
done.
how cute.
Job.
Yeah. See, this is why every child should be a Boy Scout, so you can sew and hem.
It's still doing it. Are any of these fields non-numeric?
It's just partition.
Oh wait, which kNN are you using? Are you using kNN estimate or are you using classification?
Class.
Using classify.
Okay.
Yeah.
Is that wrong?
No.
No, that's right.
That's right.
I remember he had this problem in class too, but I forget how he fixed it.
Did we have the first row selected?
I do. Hold on, it takes a second. There you go. The churn I put in the output,
Yeah.
and it's okay. And then I just kind of selected everything.
Everything but partition. Don't do the part. Yeah. Maybe it's unhappy about pulling the partition out.
No, it really is partition. It because it's and if I try to put it, it says it's non-numeric.
Yeah.
So
Yeah.
Okay.
Now say. I'll try it. Okay.
Mark, what's the difference between fixed K and search 1K? He mentioned it in class, but I couldn't.
So fixed K, so the K neighbors move up. Yeah, right there. So fixed K only searches that, only does the nearest neighbor for that K. So if you put 5 in there, it only tries K equals 5. If you do search 1 to K, it will try Ks 1, 2, 3, 4, and 5.
Okay.
And I think it wants us to do it to 10. Yeah, K 1 through 10. So put, yeah.
partition data. Use partition variable. Done.
Got this.
Rescale, standardization,
Uh-huh.
done. And then next. I think these are the ones you wanted, right?
Yeah.
Do I care about the score validation or no?
Chart everything.
Yeah, go ahead. It doesn't hurt.
It just crash.
It'll take an hour and a half to
Yeah.
to execute.
Oh, it's pretty fast.
It'll take a bit still. This is the saving part of it.
Yeah, this is the comforting part where it's just a blank white screen, which is also the screen of death, you know?
Well, this one's a lot better because it's only 1,000 records, right? Or actually, no, it's 2,000. So it's better than what you had. It was like 10,000.
Cool. Let's.
So scoring is k equals 9.
Nice. And k equals 9 is 15, so that's the lowest misclassification.
And we're looking for a 0.6245 on the test set.
Test set.
Test.
Look at that right there. Booyah. You get your KNN badge.
Is this the bad score though? In terms of
F1 score.
yeah.
This is the score basically of the ratio of specificity to sensitivity, like essentially how well you're able to separate between true negatives and true positives. If you remember that that chart of like, you know, how much these populations overlap.
Yeah.
So it means that we're not getting a lot of great separation between the variables, but of the different K options, this one seemed to be the best.
So this one is 14% error. If you look at the training, it's 17.
That's not.
Validation is 15. So it's actually getting, oops, it's getting better.
Better, yeah.
So there's an overfitting.
No, that doesn't seem to be overfitting.
Because it's not too great of a
Yeah,
difference.
overfitting means it's like really good and then gets really, really bad and bad and really, really bad. That
Yeah.
means you've overfit.
Yeah.
No, but this is
percent-
consistently getting better, right?
Training is 17.
Yeah, training 17, and then it dropped to 15,
Oh yeah, look at that.
and then it dropped to 14.
14.
Oh yeah. Huh.
Wow.
All right.
So what is that then? That's not overfitting, but it's
No, so
going
there's
to-
another thing called a bias, but I'm not sure how bias. So there's two things in just like in statistics, you have a bias and variance, where you know if you look at the equation is usually mx plus b, where that second term is called the bias or the offset from 0. And then variance is how much it varies, the standard deviation. So you do have to worry about bias and variance in problems, but I don't know how to look at bias in here. That might be a question for Andy. I'll have to look at it. These look, I've seen worse.
So for the F1 score, is there a number that we're looking for?
No, I mean, you want F1 to be as close to 1 as possible.
Okay. And is there a number that's no good for sure?
0.
Like a cutoff line, I'm just wondering.
Yeah.
Or it's all like data dependent.
It's all data dependent.
Okay.
Because really, you're looking at performance of algorithms to algorithms. So it may be that within a data set that it really is hard to distinguish between these, you know, two different populations. Because at the underlying all of these mathematically is that you're saying that the reason I can distinguish between a 0 and a 1 is because they come from a population that is looks different than each other. That zeros look like zeros and one look like ones, and there's no mistaking the two of them. And if it really is random, like there's really no difference between what makes a zero and what makes a one, then you won't be able to make that separation. And so that would correspond to a very low F score. So statistically speaking, this is saying, okay, there's quite a bit of separation between a zero and a one here. We can tell them apart. And in this particular case, you know, you do so with an F score of 0.64. If you had another algorithm that had 0.84 and wasn't overfitting, you would say, well, that algorithm works much better on this test set. That's basically it. You just compare between algorithms. You don't.
The numbers. Okay.
Yeah. And the book may say something maybe about what an ideal F1 score is. I'll go look and see if it does. But in general, like, you know, so for instance, that college one that we did, the Dana data set, where it predicted everything was a zero, that nobody dropped. The F1 score for that was NA because it was divided by a zero. Because there were no true negatives.
I remember.
Yeah.
Okay.
All right, am I up?
Yep.
All right, so going to next one is problem 19, which has the data credit score data set. Okay, looks like we got to do, reading up on it, it looks like we got to do a kNN predicting people's credit score, which is a continuous number, not a category. So that's going to be a estimate. Looks like we got to do 1 to 10K. And then the credit score is the output variable and all others are input variables. And then we're standardizing it. So we're going to go to predict, k nearest neighbors. We're going to log in because apparently that's what you get.
Exactly. Password is password.
Password is password.
Did I tell you guys that I forgot to update this when I was taking the quiz? And then I opened it up and I was like, oh, it's expired.
Oh no. You didn't actually have to run the software for the quiz though, right?
No, but I wanted to just double check the drop-down menus.
Okay.
And then I couldn't even do that because my thing
Right.
was expired.
That is the thing of nightmares. I'm going to have that nightmare now. That's the new waking up in class and having to do a presentation naked nightmare. It's the waking up and not having logged into your kNN program. All right, so
And real quick, yeah, so F1 score of 0 is the worst. F1 score of 1 is the best because that means that you have perfect recall and perfect precision. It says that, yeah, you basically compare an algorithm by looking at its F1 scores, and the higher one is generally better. But it might also be that the algorithm that has an F1 score of both classes that are close to each other might also be better. So it really depends on what you care, the question you care about answering. But
all right, guys, so we are doing a kNN regression or a kNN prediction because our credit score is a continuous number instead of a categorical score. So we're going to take our credit score, dump it into our output variable. Then we're going to take everything else except partition, dump it into our selected variable. We're then going to go over to our parameter screen, first button there, change the output, use the variable, which is the partition field. We're going to rescale this as standardization because that's what the problem is asking us. We're going to search a 1 through 10K. Going to change this to 10. And we're going to go over to scoring and give ourselves lift charts for everything. And then we're going to hit finish, and it's going to take an hour and a half because it hates me. And
You did rescale, right?
yeah,
Yeah, you did.
yeah.
Yeah. Okay. Good.
Sorry.
Perfect.
We had to do this a lot for our data set for the data project. And so I have been operating kNNs on autopilot lately.
Oh, nice.
All right,
Really?
so wow, look at this. Our K10 is the best one.
All right.
And so looking at our, hold on, let me hide this panel.
It wants the RMSE for the test set.
So, sorry, hold on, let me move this panel real quickly. There we go. So let's go over to our test set. So it got better too. Oh wait, no, it didn't.
Yep.
Yeah, it did. It did get better.
51.4314.
Yeah.
That's it.
Perfect.
Okay. And then what does it say about how does it compare between the test set and the validation set?
So the validation set is slightly worse. No, almost identical actually.
No. Look, go back to the test score, RMSE.
Oh, sorry, I was using the output score. Yeah,
Yeah.
here. So it's a little bit worse for validation.
Training score is 5.6. What the hell? Oh, that's the error. It's
Yeah.
really low on the training set. That's the error. And if you look at the test and validation,
Yeah.
Well,
jumps up to 56.
Yeah. So from 5.6 to 56.
Yeah.
Wow. So that's overfitted, I'd say.
That,
If it's a magnitude of 10
yeah.
and then 51 back down again.
Well,
So I'd
it's still pretty big though. Let's look at the lift chart. See if we see anything there. Yeah, I agree. It seems to be overfitting.
Well, so that's the decile chart for the lift. That tells us
That's not good
nothing.
at all. Yeah.
Nothing. And then we go into our validation lift chart here. That also tells us nothing.
Yeah.
And
Well,
then
look at the go back to the lift chart and look at the ROC.
Sure. For test?
Yeah.
Hmm.
Or gain? Well, I guess gain's not.
Gains tell us the squat. I mean, it's basically chance.
Yeah.
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 it was
And then you
terrible.
Yeah. And then going to training. I mean, the training chat still doesn't tell us much.
Yeah.
The gain chart on it. Barely.
Yeah. All right.
So
Not
this
a good
data
test
set, it is not helpful as is.
Yeah. All right.
Cool. Who's next?
21.
So when that happens, what do you do? Like your data set is non-conclusive.
You spend more time exploring the data, trying to understand why that is. Is there not any separation between the variables? Do variables need to be transformed maybe? Are 9 of the variables garbage and 2 of them are good? You know, so you really have to go back to data exploration, what's called data engineering at that point. And, you know, so in business practice, you would go back to your data analytics team and say, look, this is what I'm getting. This data isn't separable. Can you go try to figure out why that is and, you know, get better data? So you might have to go study again. You might have to do a different collection. You might have to do better filtering, try to narrow down the data set and find if you can find a small subset that does work well, kind of work out from that. Or, like I said, understand each of the variables and maybe you need to transform. So this was all on standardized data, but you know, maybe it would work better if you took some of the numbers and used a log score on them instead of just the raw numeric value.
I'm gonna run a linear on this as well using best subsets to see if I can find out if there
There you
any of these variables are trash and we can get rid of it.
Try explanatory.
Yeah.
Yep. It's another good thing to do.
So based on the RMSE, we can tell already that information alone that this is overfitting.
Comparatively, yeah. Remember that you have to look at it. It's not that it is a difference of 50. It's that it's a 10 times worse than the original one, right? Because you can have RMSEs that are in the millions.
Right.
And so then a difference in 50 when it's a million doesn't really matter.
Right. Ben, are you going to share screen or?
Oh yeah. Oh, sorry. I just love, now that I know where all these buttons are, I just love playing around with them and seeing what crap I can find. So after running everything, what we have right now is the lowest mallow score is.
Yep. You want to sort by mallow.
Yeah. So sort. So the smallest mallow score is your 7 coefficients, which is your subset 59. And so if we go up here and go to our subset 59.
So is it really the smallest mallow score? I was under the impression that the closest you are to your coefficient, number of coefficient.
Kind of the same, smallest and closest. It's not a hard and fast rule. They should be roughly the same order of magnitude, and smaller seems to be better. But if you have one like 7 variables that has a mallow of 7 and one that has 9 variables and a mallow of 9, both of them might be okay.
Yeah, I mean, you can also weigh it against the R2. So we saw that was what, 59 was
That's
our
true.
lowest mallow. And then if we run it against the highest R, you can kind of see that, okay, it looks like, you know.
The 8 is, yeah. So does that answer? Yeah, so Amy, your observation is right. You know, maybe if you look at the R squared, it's just the smallest number. And 68 uses all of the variables.
Yeah, it does, but it's giving you a probability of NA, which does not make me feel very hopeful
yeah.
for it.
Sorry, I just saw that. I don't know what that means.
Yeah,
I don't know what the probability score means.
I mean, it just kind of, I feel like it might be just, it's kind of junky. And the 59 is, there's not a big difference between 59 and 66. Yes, it's one more coefficient, but it's 0.00002.
And what are the p-scores on 59 on that subset?
And the p-score is.
And Amy, were you trying to say something?
No, I forget. Actually, I was gonna say, well, because are we choosing 7 maybe because parsimony?
Yeah,
Sure.
I think 7 for parsimony would be great. I also don't know why this works for him and it doesn't work for me.
I've never gotten that to work. I don't know how he does it at all.
Yeah, it just doesn't like it when I do it.
Something. Or maybe he has like the full, maybe like the super license version lets you do that, but the $25 student license doesn't do it.
Yeah, so basically, let's rerun it with everything except homeowner and bureau inquiries.
Sure.
So let's see what that gives us. It's from the kNN. So I said without bureau inquiries and without homeowner. And then that, we're partitioning, we're rescaling data. We got all of our charts. Okay, finished. Jeopardy music plays.
I know. I've been thinking the same thing.
Trigger happy. You're so fast.
Sorry, I just click, 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 click. Get data. See, that's what it is being a scientist. You're just lazy. You just like shoving shit into the machines, and then you just sit there and wait for data. That's the job. Is just waiting for a machine to kick you out data.
Don't forget about the maniacal laughter. That's very important.
It's true. It's true. All right. I mean, so we go from now 6.7 on our training to still 56.
Still overfit.
Still overfit. It's still junk. And this drops even more. This drops from, actually, this one's a little bit better because the last one dropped from 56 to 51. This one dropped to 52.8. So
I don't know if you can read too much into that.
Yeah.
But all right. Decile chart.
Yeah. Not much difference there. That's the test. It's validation.
Not much.
So data needs a lot more manicuring. Cool. All right, who's next?
Yeah, or there really is no correlation between these variables. You know, you need something. You're missing the magic variable.
Yeah.
All right, 921.
I have a question on the ROC chart and gain chart. I
Yeah.
thought we were just looking at ROC chart instead of gain chart. Or are we looking at both?
That's a good question, actually, because one of the things too, I saw that like lift chart was like, I thought the ROC chart was the lift chart, but it turned out to be, they're like two separate things.
So the gain chart is usually used in business settings because you want to know how much better the algorithm is than just using the raw data set and randomly pulling. I don't think it's used really outside of the context of business. I think in pure data analytics, it's really the ROC that's used.
Okay, thank you.
Victoria or Jimmy, do you guys want to do 921?
I would, but every time I go on ASTM with Zoom, I get kicked off the internet. I don't know why that is. Ben, maybe you can tell me why that happens.
What's your bandwidth at home?
I think it's pretty high. I upgrade it, but for some reason, it's only the personal Zoom ones. For some reason, when I'm in class with Andy, I don't get kicked off. But every time I do ASTM, like in a smaller group, my internet completely kicks out.
That's super weird. And you're not running a VPN?
I am on VPN. That's probably why.
That's why. Yeah.
Oh, really?
Yeah. Because you're probably trying to connect to multiple servers at the same time, and the VPN doesn't like that.
Got it. Okay. Victoria, do you want to take a stab at this one? I could walk you through it. I just don't want to run ASTM right now and get kicked off.
Okay, let's do that.
That was a deep pull there, Ben.
What?
I said that was a deep pull on the VPN.
That was crazy.
It's not a bandwidth issue. That means it's networking. First would be a VPN, which is the most common thing for people. Second would be it's a firewall setting. Third would be it's a setting with some sort of ad blocker through the profile. This is why people ask me to do IT. I'm
just saying, like every time you say, don't ask me IT questions, you have the answer.
I managed IT for so long. It is literally the hardest job in the world because like no one cares about you until nothing works. And then all of a sudden you're not doing your job.
Right.
Okay, let me pull up the textbook real quick. Give me a second.
I was about to ask you my router issues.
Sure, bring it on.
I don't know why it's been so unstable. It like kicks me off, and we're searching for a new router for
Do
the
you have
Black Friday.
QoS activated? Because if you have Xfinity, QoS does not play along with Xfinity. I discovered that last week when we upgraded our bandwidth.
I don't know QAS, but we have Sail Internet, which is like satellite, I believe.
But what's the router that you have? Do you have a Netgear?
Yeah, it's a Netgear.
Okay, so log into your Netgear router, go to advanced and go to QoS and make sure it's disabled because it doesn't play around with cable internet that well and also does bandwidth restriction. And you'll also feel like if it gets overburdened, it does a lot of taxing on the processor for the router and it causes you to kick sometimes. So
Okay.
make sure that that's disabled.
What is that QoS?
QoS is bandwidth optimization. It is a tool. I use in quotes because it's a tool that the router uses where it sees what IP address you're hitting and prioritizes the bandwidth accordingly. Like if you're connecting to Steam, it'll see, okay, you're connecting to Steam, so this is gaming. So I'll keep this many rows of stream up for the Steam. Are you connecting to YouTube? Okay, what are you doing? Are you just connecting to G Drive? Oh, that's not going to use that much bandwidth. I'm going to like a lot less bandwidth for that stream of data. And so it uses a lot of the processing power for the router. And Netgear is probably the worst for it because even Netgear says they have a really good 4-core processor on their routers. It overheats really quickly and you'll start getting kicks.
Huh, interesting. Well, look into that. Thanks.
Okay. You want me to read the problem or do you want me to just?
I think do you guys all have the problem in front of you or?
Yeah, I have it. I was just reading it just so I knew what I needed to do, not necessarily for the benefit of the YouTube watchers.
Should I read it out? Do
Yeah.
you want to read it out?
Sure, Ben.
Yeah.
So this is 21, right?
21, yep.
Okay, as an intern with the local Home Builders Association, you have been asked to analyze the state of the local housing market, which has suffered during a recent economic crisis. You're provided with 2 data sets in the file Housing Bubble. The pre-crisis worksheet contains 1,978 single-family homes sold during the 1-year period before the burst of the housing bubble. These 1,978 observations have been split into training set and a validation set. The post-crisis worksheet contains 1,657 single-family homes sold during the 1-year period after the burst of the housing bubble. These 1,657 observations have been split into training set and validation set. The data in both pre-crisis and post-crisis worksheet have been appended with the same 2,000 observations designated as a test set. This test set corresponds to homes currently for sale because they have not yet been sold yet. Each of these 2,000 observations has an artificial value of 0 for the sale price. Consider the pre-crisis worksheet data. Construct a model to predict the sale price of the K nearest neighbors with K1 through K10. Use price as the output variable and all the other variables as input variables. Standardize the input variables to adjust for the different magnitude of the variables. And then once we do that, we have to find 2 parts for question A. What value of K minimizes the RMSE on the validation set, and what is the value of the RMSE? And 2, use the kNN with the value of K that minimizes the RMSE on the validation set to predict the sale price of the houses in the test set. So I think 1 is easy, 2 is a little more complicated.
Mhm.
Yeah.
Yeah. So we're going to go ahead.
Classify. So we'll go to classify.
Are we not going to predict? We're going to classify?
Are you
Construct
trying to solve for a continuous number or are you going to strive for a categorical number?
We need to, what value of K minimizes? We need a numerical number, so it's predict.
predict, right? Predict the sales price.
So we're in predict, kNN.
Yep.
There we go.
Victoria, we can't see the window.
Oh, you know what?
Could you share your whole screen?
Okay, you gotta tell me how I can go there. That was the same problem before, where you can see the data set, you can't see the rest.
You have to share the desktop instead of the program.
Because you're not seeing any of these. Yeah.
That's okay.
Yeah, because somehow I split up my desktop with the Microsoft Excel sheet. Yeah, and the thing is that my Microsoft Excel sheet is split up from the box, the window of Analytics Solver. I don't know why. Jimmy, you want to try or?
Let me open it and see if I can. Give me 1 second. I have the file open. Let me just log in real quick to make sure I don't get kicked off of the internet. Actually, let me get off of VPN first. Can you guys still hear me?
Yep.
Okay. Okay. You guys see?
Yep. And you're
Okay.
still with us.
Yay. Okay. So maybe the VPN worked, Ben.
There we go.
Okay, let's try this. Okay, I'm gonna go to data mining, predict, and data range. Let me see if I pulled all the data. Yep, that did it. Okay. Okay, I want all of them. I want price as my output.
The output.
I want
The
everything
rest
but
except-
partition.
Except partition.
Okay. I want to partition my data.
Standard. Oh.
Right.
And also search 1 to K or 10.
Yep, search 1 to K and then rescale the data. And I want to standardize it. Okay. And do all of them.
Yeah.
You want a detailed report? Yeah.
Yeah.
Your last checkbox is missing. Score
The-
test.
the-
Oh, whoops, sorry. Okay. That's it.
Ah, that was the fastest one yet.
Damn, somebody must work for Intel.
So scoring will be done using K7.
Okay.
Okay. Let's see what this.
So on this one, he gave us the
Mm.
price of the first house in the test set.
Test set.
Yeah.
Whoops. Sorry.
You can use use the navigation charts up above.
Oh, here.
Yeah, I'll put navigator. So go to testing, probably prediction summary
Yeah.
or
Okay.
details. Yeah, there you go. Okay, so the first record it had 108, 875, 50.
Perfect.
Boom.
Okay. We ran it correctly, Victoria. So that's good.
Crushed it.
Okay.
So what was the first question again?
What value of K minimizes the RMS on the validation set? And what is the value of this RMSE?
Let's go to the validation set.
You want to use the inputs. That's where it has the that's where it tells you which K it's selected.
Yeah, so that was K7.
Yep. And the RMSE is right there.
24805.9.
Yep.
That is the lowest one. Okay.
So that's
Well-
the value of RMSE, and then says what value of K minimizes the, well, that's 7.
Yeah, it's 7.
And then it's asking the use kNN with the value of K that minimizes RMSE on the validation set to predict sale price of house in the test set.
Test set. Okay.
So that is done for us automatically. If you go back to the input chart
Mhm.
and scroll down to the kNN table, you see there it says note the scoring is done using K=7 beneath that table. That
Yep.
means that the validation and the test set details were done using K=7. So if you just go look at the test chart, the test set data that was calculated, that all corresponds to K=7.
So automatically it pulls K=7.
Yes.
Okay, all right. So that when we go into the input, is that where you go? Or hang on a second.
Yeah, this is the input tab.
Okay,
Yeah.
and when we
thing
go
is,
to the validation.
instructions- Sorry, go ahead.
No, go ahead.
So the instructions say using the K nearest neighbors with the value of K that minimizes RMSE on the validation to predict sales prices of the houses in the test set, blah, blah, blah. That's a really long
Mhm.
sentence. That's done for you. It might as well just say, go to the test details page and read off the home prices. Because it's all the validation and the test set were done using K=7.
Right. So then where do we go for the test set?
That's where we just were. That's in the test prediction
Okay,
and the prediction details right there. You see there's record.
yeah.
Go to the at the top where we can see the title. There. So it says record and it says price in dollar prediction price. So that prediction price 108,875. That's the predicted price of the house.
Cool. And is that the, oh, that's why there is different records. Okay.
Yeah.
Yeah.
All right. And then it says repeat part A with the post-crisis worksheet data.
Okay. So let me delete everything.
You don't have to. You want to keep this around, actually.
Oh, we do? Okay.
Yeah. The
I
second
didn't-
part of the third part C is to diff the predicted, the post minus the predicted,
Oh, yeah.
and find the average percent difference.
Got it. Oops, predict.
Mark, is there an easy way to do that? Are we seriously just going to have to copy and paste two values and run a?
I mean, no, there's no easy way to do it, but you can you can go to a sheet and say equals, and then
Right.
grab one column and say minus at the second column, and then divide by the first column. So you can, it's relatively straightforward to do, but there's no shortcut.
Okay, yeah, that's what I was thinking we would do, but yeah, that's a lot of data.
It is. It's a few clicks, but I mean, yeah.
Oh, not yet. We want to do KN, the search 10. Yeah.
Yeah.
I think actually on this one, I would say we want to use k equals to 7.
Huh.
I could be wrong, but I don't think we want to search. I think we want to compare apples to apples.
Okay.
How do
We
we
could try
know
it.
that k equals
Yeah.
7 on this data set is the best?
We don't, but that was the one on the other, used on the other one. And so when we're using when we're comparing the two predictions, we
Mhm.
probably want to compare K's being the same. We could try it. Let's see what happens if we search and see if it
think-
is different.
I think we haven't done the rescale.
We haven't done recent.
Yeah. Oh, we
There.
did. Okay. Perfect. Thank you.
Ooh, K9.
Interesting. Yeah, it's 9.
Well, we'll
Hmm.
see. We'll see what his
Mhm.
see what the answer is. So we're looking for 98, 894, 72.
Testing? Was it testing?
That's,
That?
yeah.
Okay.
You were right. You guys are right. Never listen to me. I'm always wrong. Your guys' instincts were
Got
really
lucky
mine.
there.
My instincts are always wrong on these. I can explain the math. I can't guess.
Mark,
Right
I think
away.
you're just too smart for these data sets. I think
I
that's
don't
the
think
problem.
so.
Is you're like 3 levels ahead.
Okay.
So what was the next part? It was
The
to take the
comparison.
average.
So we're supposed to subtract the pre-predicted price from the post-predicted price divided by the pre-predicted price and average those percentages to get the average percent change in predicted price.
Okay. But it doesn't matter what the record is, or are we supposed to match the
No.
record?
The record should be the same because we use the same partition criteria.
So Mark, you're saying that although the K is different, it's okay.
Yeah.
Okay.
Okay, let's.
Yeah, I would have said to use. My thought was that you should use the same Ks, but really,
Right.
I suppose this is saying, look, you have it. You have a prediction, and you want to look at the difference in prediction based off the best fit model for both cases, and one that happens to be 7 and the other that happens to be 9. I don't know.
Yeah.
I'll ask him about that. That's a good question for class. If this problem should be done using the same K values.
Wait, so Mark, you said it doesn't matter that the records don't tie, or it doesn't,
Oh,
because this is
Why
1979. This one is
1658.
go back to the other one. That's testing prediction. What? No.
That was the pre-crisis.
yeah, this is the pre.
Yeah. So we're using this number minus the 98 and then divide by 98, right?
Yeah, that's what I thought too.
Yeah, I would think that the record does matter. You would want the records to be the same, but
Same, right.
they're not. And
Aren't we just doing a sum, guys? It doesn't matter because we're just doing a sum, right? We're doing
Of all of
a sum.
them?
Well, isn't that the percent difference we're doing? We're
no,
doing
no, you have to do it. Is it the same? Probably is the same.
It just asks for a
It's-
difference between the two.
Yeah, it says post-crisis minus pre-crisis divided by pre-crisis.
The total of them? So it doesn't matter? Is that what, Ben, that's what you're
Yeah.
saying?
It says for each of the 2,000 houses.
I think mathematically it should work out to be the same. We do X minus Y. Divided by X. No,
Jimmy, are you just adding all the
we have to do
records
them
together?
separately.
Yeah, I'm not sure. Should I be doing that or? So this is added together.
Yeah, I don't
Mhm.
know if we can do the two. I think mathematically, I think you have to separate it. I don't think they're equal.
I mean, here's the thing though, the houses are different. Between
Yeah, that's where I'm confused
percent.
too.
That's why I thought it was a total number.
Yeah, that's what I don't understand how it's different. Is can we look at the tests at the data set? It's the same data set, right?
No, they're two different data sets.
Yeah.
Yeah,
One's pre-crisis
one is post.
and one's post. And there even in the problem, they note that there's a different value of data. Different
Yeah.
number. Yeah.
Yeah, they're completely different too. I mean, like the first one of pre-crisis is like a $15,200 land value, and the second and the one post-crisis is 18.2. So these are completely different houses. That's why I thought it was an average of all the 2,000 data sets.
Yeah, I think
Which
you're
would
right
make
then.
the
If they're not identical, they can't be. It doesn't make sense to. In his notes, he said you should do the percent difference for each individual house and then report the averages across all of them. But I agree with what you guys said.
It's just weird. They're different houses.
Yeah, because the pre and the post are different already,
Yeah.
right? So you're never going to compare apple to apple.
Yeah,
You're comparing an average of all.
yeah. No, I agree with you guys.
I mean, is it the same total count? Let's see.
Yeah, it is. It's
No.
2,000 for both of them, right?
Is it 2,000 for both of them? Then I guess
Mhm.
it shouldn't matter.
No, it's not. It's
Because the first one said 1,600 and the next one was like 1,300 or something.
right.
1,900 versus.
Oh no, it's the
1657.
same amount of count. I think we
Oh,
could
it
do it
is?
then.
Yeah,
Yeah.
it's 39. Actually, no, it's not. The first pre-crisis is 3978, and the post-crisis is 3658. So there's a different number of houses even here. I think we're just supposed to take the first. We're just supposed to take the first 2,000 in the test set. I believe that's probably what he means by.
Yeah. So sorry, when I compared the two test sets, it's
Yes.
2,000. So
Yes.
that's why it lines up.
Oh, okay.
It's okay. So this one is, I'll just label it.
So are you doing the sum or the average?
This is just the prediction right now.
Okay.
So this is post crisis.
And that's pre-crisis.
Yeah.
Okay. And then you're going to find the difference in each record.
Yeah. So this
Okay.
minus this. So that's our difference.
Yeah, that minus that divided by the first, divided by pre.
Should I take the absolute value then? Or does it matter?
Hey guys, it is the same. I was just looking at the training set, and the training set is different. However, the test sets for both pre and post are identical.
Okay.
So it should line up.
Yeah. So pre minus post over pre. And take a
Post
percentage.
minus pre over pre.
Post minus pre.
Post minus pre over pre.
I gotta put this in parentheses.
And I think it doesn't want, it doesn't want absolute value.
Okay.
So I guess post crisis, we're expecting prices to drop post, right?
Yeah.
One would
Mhm.
presume.
And we're trying to find, are we finding percentage? Let's see. Yeah, percentage difference.
Yeah.
Jimmy, that didn't work.
I know. I don't know why that didn't work. Okay.
Nice.
I don't know if you guys hear that. That is my,
Is that yours?
yeah, it's a 2-year-old son. He's like, he took a really late nap. So he's
Yeah,
like
I
going
was
around the
gonna
house.
say,
It's
he's still up.
It is the worst. It's the worst when they take a late nap and he's still up right now, walking around asking where I am.
Oh.
He wants to
Okay.
learn math.
Yeah. Okay. So, okay, now that we calculate, what are these percentages supposed to tell us per each house or per each record?
I think we're looking at it wanted us to look at, does it ask for each
Average.
record or just the average?
It says it says what percentage, where percentage difference is, and then what is the average percentage change.
Okay, so I can't take the average of all these, right? I have to,
You could plot a histogram of that.
I could do that. Average is 2%.
Yeah.
How did you do that?
I just use the average of all
Oh,
the
you just did
percentages.
the average. And
Yeah, but I don't know if that would actually work or if I'm supposed to go like sum of, was it post?
No,
I think this is what,
I think I think the way you did it was right.
okay. I think mathematically, Ben, was this what you're asking? Like it should be the same?
Yeah, and yeah, it should be. So mathematically, it should be right. The only thing that I think you could enter into is just rounding errors. There's going to be some sort of rounding error that you might have to contend with. But yeah,
Yeah.
they should be. It should work this way.
Like I should get my 2% this way too, right?
Yeah.
Let's try it. Nope.
You didn't do the sum, Jimmy. You for the minus, you should have done a minus sum. You just did a minus of the set.
Oh, sorry. So it's minus, oh, I didn't do the sum.
Mhm.
Okay. Okay, am I missing anything then?
No, they should do it. Hit that enter button. Let's see what we got.
Oh, it's different.
It is.
Yeah, I think the division makes it, because you're dividing by y, I don't think the sum is the same. Sorry, because you're dividing by x.
Yeah, I think this, you're giving the weight of all the percentages the same when you would do the average formula. This one, we're taking all of the amount into account. So I feel like this number is actually more accurate, right?
Right,
Or-
because you are actually doing it based on the price rather
Yeah.
than an
So
average.
2% versus 4%.
Yeah.
So would you say, Jimmy, that 2% is probably closer to the median because they're weighted the same, and then 4% is probably the true average?
I don't know if it's the median, but I think the true average is probably the 4%.
Yeah.
Because I think right now, like, you see the difference here. This house dropped, but we're basically giving this 9% and this 35% the same weight when we take the average of these two, right? That's the first formula. It's giving these all the same weight. This one has taking price into account. So really, if this house is doubled, it's getting more of the weight. That's this 4%.
Right, right.
Cool.
So we got that, and that's the average percentage change.
Yeah, we'll see if we got that right.
Between the pre-crisis and the post-crisis.
Yeah, we didn't have the answer for this one, but
We'll see. Hopefully he does this one in class.
yeah. Well, I mean, yeah. Comfortable with the
Oh, hey guys, he actually, I think he says that specifically in the question. It's like, report the average for all houses across the test set. This is not the same as comparing the average of the entire set of prices estimated by the pre-crisis model versus the average of prices estimated by the post-crisis model. So is that what he's referencing, as to don't just do an average of the
I think
percent
he was
difference?
telling us to do the one that resulted in the negative 2%, and that it's not the same as where we got the negative 4%.
Yeah.
But in terms of which one you would want to present to someone, I mean, I think the way Jimmy talked about it is just fine too.
Yeah. Or I guess the way he might be looking at it, yeah, it depends how you explain it. If he's saying a house is a house, then he gives them all the same weight, right? Here's 2,000 houses. Here's a change for 2,000 houses. Then it makes sense to use the negative 2%. Maybe
Yeah.
that's where he's going with that.
But if more expensive houses had a bigger drop than less expensive houses, maybe.
Yeah.
Yeah. Anyway.
Okay.
We did 4 kNN problems. We did problem set 3.
And we got done early.
Yeah.
Good job, everyone.
All right.
Thank you, everyone.
Thanks, everybody.
Good job.
I'm gonna have to figure out why my two screens are split up.
What do you mean?
You know how I can't show my window of the pop-up from the Excel spreadsheet?
It's probably just not your main screen.